In the first video, we saw that the behavior of the integral from 1 to infinity of 1 over x to the p depends on the value of p. So when p was equal to 1, we had the integral from 1 to infinity of 1 over x was divergent. And when p was equal to 3, which is bigger than 1, the integral from 1 to infinity of 1 over x cubed was convergent. In fact, it converged to 1/2. And the overall behavior looks like this. The integral from 1 to infinity of 1 over x to the p dx is convergent if the p is bigger than 1. For example, our x cubed that we looked at before, and it's divergent if p is less than or equal to 1. For example, we looked at p equals 1 before, and it's also true that the integral from 1 to infinity of 1 over the square root of x is going to diverge. Well, the proof is not very difficult. Even if we keep the general p there, we just have to calculate the integral according to our definition. So if we want to calculate the integral from 1 to infinity of 1 over x to the p, then we're looking at the limit as t approaches infinity of the integral from 1 to t of 1 over x to the p. And of course, an antiderivative for 1 over x to the p, which is equal to x to the minus p, is x to the minus p plus 1 over minus p plus 1. So we have this integral is the limit as t approaches infinity of x to the 1 minus p over 1 minus p evaluated at the endpoints between 1 and t. And this is the limit as t approaches infinity of t to the 1 minus p over 1 minus p minus 1 over 1 minus p. Now if p is bigger than 1, then 1 minus p is going to be a negative number. And as t approaches infinity, t to the 1 minus p will approach 0, and this limit will be 1 over 1 minus p. And of course this means that our integral converges if p is bigger than 1. We've already shown that it diverges if p is equal to 1, and if p is less than 1, then 1 minus p will be positive, and as t approaches infinity, t to the 1 minus p will approach infinity, and this limit will approach infinity, and our integral will diverge. So that completes the proof of the above theorem, and this is a very, very useful integral to keep in mind. We know the integral from 1 to infinity of 1 over x to the 10 will converge, and the integral from 1 to infinity of 1 over the square root of x or 1 over the cubed root of x will diverge, etc., etc.